let's have a look at question 1. At time t seconds, where t is more than or equal to 0, a particle p moves so that its velocity v meter per second is given by v equal to 6ti minus 5 t to the power 3 over 2j. So velocity is in terms of t, so it is variable. Yeah. So that means we definitely need to do something to do with differentiation or integration. So first, I'll just write v as the column vector first. It's just easier to see. So I component is 6t, and j component is negative 5t to the power 3 over 2. Right, when t equal to 0, the position vector of p is negative 20i plus 20j meter. And then in part A says find the acceleration of p when t equal to 4. Okay, so very standard. To find the acceleration, we just have to differentiate velocity. So differentiate velocity acceleration is equal to, so differentiate each component. So 6t differentiate to 6, and then negative 5t to the power 3 over 2 differentiate this. So bring down the power 3 over 2, and then minus 1 the power. So 3 over 2 minus 1 should be 1 over 2. So simplify this, we have 6 and then negative 15 over 2 t to the power 1 half. And then they want us to find the acceleration when t equal to 4. So t equal to 4 will give us a is equal to 6, stay the same because it's already a constant, and then negative 15 over 2 times by 4 to the power of half. So then that would be 6, and negative 15 over 2 times by 4 to the power of half, that should be negative 15. Yeah. Then that would be the answer for part A. And then part B, find the position vector of p when t equal to 4. Okay. So again, if we differentiate velocity, we will have acceleration, and if we integrate velocity, we will have the position. Yeah. So let's do the integration. So integrate velocity give us the position. So if we integrate 6t and negative 5t to the power 3 over 2, then that is equal to plus 1 the power divided by the power. And then again, plus 1 the power, 3 over 2 plus 1 is 5 over 2, and then divide by the power of 5 over 2. And don't forget to put plus c. Yeah. So then we will have simplify this. That will give us, so 6 divided by 2 is 3, so 3t squared. And then negative 5 divided by 5 over 2, that will give us just negative 2. So it'll be negative 2t to the power 5 over 2, and then plus c. Yeah. And it says when t equal to 0, the position vector of p is negative 20i plus 20j. So that's what we need to use to work out the value of constant c. Yeah. Let me just make some space. Okay. So now substitute that in. So when t equal to 0, r is equal to negative 20 and then I, and then 20j. So substitute that in. So we have negative 20 and then 20 should equal to 3 times by 0 squared. That would just be 0. And then negative 2 times 0 to the power 5 over 2. Again, 0 to the power anything is 0, and times anything is also 0. So just plus c. So we have c equal to negative 20 and 20. So that means r is equal to 3t squared, and then c is negative 20, 20. So minus 20 in the I component, and then negative 2t to the power 5 over 2 plus 20 in the j component. So that will be our position vector. And we're looking for the position vector of p when t equal to 4. So if t equal to 4, substitute in, we have 3 times by 4 squared minus 20 for I component, and negative 2 times by 4 to the power 5 over 2 plus 20 for the j component. Now we just have to put in the calculator. So 3 times by 4 squared minus 20, that is 28. And then negative 2 times by 4 to the power 5 over 2, plus 20, that will give us negative 44. Then that will be our final answer. So 6 marks in total. Yeah. So quite a standard question. You just have to differentiate the velocity, give us acceleration, and then substitute the time in part A. And in part B, just integrate velocity, then that will give us the displacement. And always remember, put plus C. Yeah. And you substitute the initial condition when t equal to 0, position equal to negative 20i plus 20j. Then you will work out the constant C, and then substitute the time to get the final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.